Alright, let's do example number 1. So there is a 3-point charge lies along the x-axis. So it lies on the x-axis as shown in this figure here. So calculate the magnitude and direction of the total electrostatic force exerted on charge 1. Okay, so we are only focusing on charge 1. Okay, so firstly what you need to do is you have to be able to draw the electric force vectors. So how do we do that? This is kind of like drawing a free body diagram, but this time you will be doing it for charge lah. Okay, so this is your kononnya lah, this is your Q1. Okay, so that is your charge number 1, and then we will firstly look at the what is being experienced from charge 1 and charge 2 lah. Okay, so what is this two experiencing with each other? Oh my god, why am I talking like that? But it's okay. Okay, so alright, so this is a positive and this is a negative charge. As we all know, unlike charge will attract each other lah. Okay, so because of that, the direction of the arrow will be going towards the negative charge. Okay, why is this going towards the negative charge? Is because for a positive charge, the electrostatic force will be going out of the charge. Okay, so it will be going out of the charge. You will be learning about that in the next subtopic. And then for negative charge, it will be going into. Okay, so the force will be going into the charge. Okay, so this will be our let me Q charge. Sorry, not charge, force. Okay, force by charge 2. No, force by 1 due to number 2, due to charge 2. I think it's like that. Yes, okay. Right, because I'm confused because there's two ways of writing that. It can be by and then on, or it can be on charge 1 by charge 2. Okay, so we will be using the first one lah. Okay, so this is force due to charge number 2 on 1. Okay, then we will be looking at the charge number 3, so we will be ignoring this one. So for positive and positive charge, this is gonna produce a repulsive force because they are like, okay, they are similar in charge, so they will try to get away from each other lah, gitu. Okay, so positive and positive, so the direction will be going away lah, I mean going to the left of the charge Q1. Okay, sorry. Okay, so again write force due to charge 3 on charge 1. Okay, so now we have the force vector. We can then use the Coulomb's equation. Okay, so the Coulomb's equation is basically just kita kira one by one lah. Okay, untuk this one and then this one. Okay, so force to 1 KQ2 Q1 over R12 square. Okay, don't take the sign. Okay, this is just the magnitude. Okay, so the negative is just for the charge, we don't include it into our calculation lah untuk electrostatic force. Okay, so if you calculate that, you should get 150 Newton, and then for the other one you should get 37.9 Newton. Okay, so for this one F21, the direction is from our force vector here lah, the drawing. So this is to the right and then this one is to the left lah. Okay, so how do we, this is not the end, you have to add them together lah, you have to add this two together. All right, so since this is a vector, you should add them as a vector lah. Okay, so F on charge 1 will be equal to force 21 plus dengan force 31 lah. Okay, just add them both together. Since this is in the x-axis, we can just add them together lah. Okay, kalau they're the y-axis, you have to resolve it lah. Okay, so this will be 150, since this is going to the left, this force is going to the left, it will be negative. Okay, so negative 37.9, then it will be equal to 112 Newton. So the direction is to the right. Why is it to the right? Is because it is positive lah. Alright, okay, so that is the answer, the solution for example number 1.